So we're going to go over a few examples of logarithmic derivatives. So the first one is just a regular natural log. The second one is a log base of something that's not e, because natural log is just a log base of e. And then we're going to have a constant to a variable, and then another log base of that is not e, which is we have 2 in this situation. So let's start off with the first one. We have natural log of 1 over x. So when we take the derivatives of natural log, so whenever we take this of natural log of u, this is equal to 1 over u times du over whichever we have, which is dx in this situation. And if we have, in this scenario, dx of like a log base, and we'll say 10, for example, for u, we get 1 over u times 1 over natural log of 10 times du over dx. And then for this little constant here, whenever we take the derivative of a constant, so I'll call it a to a u, this will give us a to the u times natural log of a times du over dx. So this will be our guideline to how to do this. So let's follow this guideline for natural log. So we got our u here is 1 over x. So we get 1 over x, and then times our derivative for 1 over x. So 1 over x is just simply x to the negative 1. So if we take the derivative of this, we get negative 1 times x to the negative 2. So this is negative 1 over x squared, right? So let's simplify this even more. 1 over x is simply x over 1. You basically flip that. And then times negative 1 over x squared, and that'll simplify to negative 1 over x. This cancels out for this power. Now let's do the second example right here. So let's follow this guideline of the derivative of a log base. So we have 1 over u, which is 1 plus cosine of x, times 1 over natural log of the number we have, so 1 over natural log of 10, times, and then we have du dx. So the derivative of 1 plus cosine x is just negative sine x. And I'll just put that over 1. So this gives us negative sine of x over, and then in parentheses, 1 plus cosine of x natural log 10. And we can rearrange that however you want. And let's do the last example. So if we follow our guideline that we put up here, we have a product rule, and then we have both a log and a constant. So if we do the product rule, we have to take the derivative of the first thing. So the first thing we have is basically this. So we have the derivative of the first is 2 to the z times, we have natural log of a, which is a constant, so natural log of 2, times the derivative of z, which is dz, and we just get 1. So I'll just put 1 there, times our second, which is just log 2 of z, plus the derivative of the second, which gives us 1 over z, times 1 over natural log of the base, which is natural log of 2, times, and this gives us the derivative of z, which is just 1. So I'm going to put 1 over 1 here. So if we simplify this, we get 2 to the z natural log of 2 log 2 of z, right? Plus, and we have 1 over z natural log of 2. So if you wanted to simplify this, you could as well, but there is no need to simplify in this situation. So that's how we demonstrate the 3 types of logarithms, where we have our basic natural log, we have our log base to some number, and we have a log base to some number, and we have a constant to a variable.